Hi students, welcome to this video which is to teach you about this concept called covalent bonding. Now in this video we'll learn about two things, which is first, how exactly are covalent substances formed? Secondly, how do we actually draw the dot and cross diagrams of covalent substances? Now, let's have a quick short recap about some of the things that we have learned in the previous chapter on ionic bonding. You may still recall that atoms of different elements may either lose or gain electrons, or they might even share electrons. So you have come across this concept called ions. And why exactly do atoms form ions? It's because atoms wants to have a stable electronic structure. Now, a stable electronic structure means that all the valence electrons that's outside, right, completely fills the shell. So they can either do that, whereby metals will transfer electrons to non-metals, right? In this case, they form ions. Or you can have two non-metal elements coming together, whereby they share electrons. And in this case, they form covalent molecules. Right? So in this video, we are going to learn about what exactly is this term called molecules, and how do we go about drawing the dot and cross diagram for such structure. Now, covalent bonds are formed between atoms of non-metals, right? So what happens is that they will actually share electrons with other non-metal elements, and through that they will form what we call molecules. So the sharing of electrons forms molecules, and by doing so, this allows them to attain a stable electronic configuration, which means that the valence or the outermost shell is fully filled. So some of the possible covalent bonds that can form, right? The bonds that's being formed is called covalent bonds. So it can either be formed between elements that are the same, right? So for example, let's say that we have a molecule called hydrogen molecule, right? This is actually known as H2. Okay, H2 is hydrogen molecule. So within hydrogen molecule, we know that there's a H atom, right? And if you look at the periodic table, we know that the H atom has a certain number of electrons. It actually has one electron only. If it has only one electron, we know that when we write out the electronic configuration, which is the number 1, we write it as 1. So how to become stable, right? To become stable means that you must have a fully filled valence electron shell. Since this is the first shell, because there's only one electron, right? It's in the first shell, that means your hydrogen looks like this. Right? So this first shell of this hydrogen, how to make it more stable? To make it more stable, it needs one more. Right? So that you can put in one more, so that it can have a complete 2 electrons within the shell. Now, but the formula is H2, right? Which means that there is another hydrogen atom. So let's say that there's another hydrogen atom. Let's write it in blue. This atom will also have an electron configuration of 1, which means that you also need one more to form a stable electronic structure. So this means that when these two atoms come together, right, in a ratio of 1:1, they will actually bond together, sharing electrons to stabilize everything. So what will this look like? Now, one of them, we represent them using the red circle. The other one, we represent them using the blue circle. So you learned in the previous chapter that in terms of ions, right, what happens is that these electrons, right, may be lost, or you might even add in another electron. That's to form ions. But because in this case, whereby both of them neither want to lose nor want to gain, they will actually share. Right? Sharing means that what will happen is that the two circles will come closer together. They will actually overlap. So they will cross each other in this manner. Right? It's like sharing things within two rings. One of it is the normal blue H, one of it is the normal red H. Right? But now that they come together, right, you will realize that the area that's in between them, this spot over here, is showing what is being shared. And what is being shared now is this one circle, one dot electron, as well as one of the cross electrons. Now, where does these electrons come from? The dot comes from this one, and the cross comes from this one, right? Hence sharing the electrons. So what exactly is this trying to tell us? This shows us that now, if you look at the red circle only, we realize that this hydrogen actually now has one dot and one cross. That means it's already achieving its 2 electrons. So it's a stable electronic structure. If you look at the blue hydrogen atom, within the shared area, there's also one dot and one cross. So it's also stable because now it has 2 electrons. So sharing allows non-metals to achieve what we call the stable electronic structure without needing to lose or gain electrons. This is because non-metals and non-metals, when they come together, they will neither lose nor gain. In fact, they will share. So this entire concept is what we call covalent bond. And that means over here, what is being formed is actually you will form a covalent bond. Right? So we learned in the previous chapter there's something called ionic bond. This is actually what we call covalent bond. Let's take a look at a few more examples and we see if we can get a hang of it. Okay. Now what if it is different elements, right? So just now was both is hydrogen. Now what if let's say I have a substance called water, right? Water exists as a molecule of H2O. So together there's some form of bonding that holds the H and the O together, right? In terms of the H atom, we know that it has a configuration of 1, which means that it needs 1 more. For the O atom, we know that it has an electron configuration of 2.6. Now to become stable, right, this oxygen will need 2 more. Now you realize that both of them need more, right? But none of them is willing to lose. So what can they do? They will share, right? So to share, what this means that we need to look at how many each of them need and we try to balance up. So in this formula, it's called H2O, which means that there must be 2 of the hydrogen, but there's also a O, right? So there must be 1 of the oxygen, right? Oxygen has 2.6, that means there's 2 in the middle, there's 6 outside. Yeah, and you'll notice that this oxygen here, these 2 electrons actually are not stable because they will need 1 more to pair up with them. That's why it needs 2 more electrons. This hydrogen here, these electrons are not stable because they need 1 more so that it can have a completely filled electron shell. That's why it needs 1 more for each of them. So what can happen now? What happens is that this hydrogen over here, this electron, will actually be shared with this electron over here. Right, so they will overlap and share the electron. This hydrogen's electron over here will then overlap with this oxygen's electron, overlap, and then share together. So what will you get in the end? You need to draw some overlapping, right? So the oxygen, we know that it looks like this. There's 2 shells. But now to show that the hydrogen is being bonded to the oxygen, we have to draw the circle overlapping on the oxygen. Draw the circle overlapping with the oxygen with the symbol H inside. Now we know that the oxygen actually has 2 electrons that's in the inner shell already, right? So what exactly is the bonding? The bonding is between 1 of the dot with 1 of the cross. So when you draw the electrons, you have to draw 1 of the dot inside the shared area and 1 of the cross inside. Same over here, 1 of the dot inside and 1 of the cross inside. Now, so let's count. Oxygen has now used up 1, 2 of the crosses that's on the outer shell. So these are the 1, 2. It's now left with 2 here and 2 here. So we'll put it in by drawing it at the bottom here. And this is how a water molecule looks like. Now, when you start drawing covalent bonding, it will tend to be a bit more confusing. So what you can do is to really practice and slowly draw this out first so that you can deduce what should be the formation. We will try out a few more examples, then I will pass the time to you to practice on your own before submitting your answers. So let's take a look at the next page. Now this entire next page is really here to guide you and give you a chance to practice, right? So there are some group practices which I think you can take note of, right? So how do you go about starting to draw a structure? Okay, so before you draw a diagram, right, it's important for you to first determine what is the electronic configuration of each of the atoms that's inside. So what you can do is find out what's the electrons based on the periodic table and write out the configuration. Next, find out how many more do you need for sharing, right? So by knowing how many you need for sharing, you can deduce what we call the ratio. So I'm going to show you an example later on, then you will eventually draw it. Now in terms of drawing, right, a few things to take note of also. Start by drawing the overlapping overlapping atoms. Okay, then slowly put in the electrons first into the overlapping area, then start to put in the remaining electrons, and at the end, please make sure you check. Okay, it's important to check so that you don't add in any extra electrons that's not supposed to be there. So let's take a look at one example, which is oxygen. Okay, let's try out oxygen together since we have talked about hydrogen already. So inside oxygen, right, we know that the formula is called O2, right? So that's oxygen, yes, O2. Inside O2, there must be an O atom and another O atom. Now, for each of the O atom, we know that if you use a periodic table, O has 8 electrons. right? So if O has 8 electrons, we know that in terms of the configuration, it will be written as 2.6 and 2.6, right? So that's 2.6, 2.6. How can they be stable? We want to make sure that we can fill this up all the way until we reach 8. Fill this up all the way until we reach 8. But this time around, both of them are non-metals, right? In the periodic table, so they will share. So how many do I need to share? I need to share 2. I need to share 2 more to be stable. So in terms of ratio, right, it's a ratio of 1:1. Now the ratio helps us because it allows us to understand how many things are we going to draw. But to be very honest, you may not need this last part on ratio if you already understand how many electrons are needed. So what's going to happen is that if you need 2 electrons, you must also contribute 2 electrons, right? So because it's sharing, it must be fair. So let's say that you have one of the oxygen over here. Is 2.6, and yeah, the other oxygen, which I'm going to draw in blue, is over here. Notice that I'm using cross for a different oxygen, right? Because this is called dot and cross diagram, right? And to show that there are different electrons. Now, so we added in 2 new electrons. Okay, this should be the structure of oxygen. So what can you do to make sure they share? If you look at all the electrons, right, you realize that we are only concerned about the outermost shell, the outside one. We don't care about the inner shell because it's already filled already. So the inner shell are very stable, it's not going to react. But the outside shell, they might react, right? So the outside shell over here, we need to look at them and see how they might react. So one of the ways is that, look at the electrons. This is a cross that is by itself, it has no partner, right? It's not paired with something else. This is an electron that's by itself, it has no partner. This is an electron by itself, and electron by itself. So the idea of covalent bonding is that they must share, right? And sharing involves those that are lonely by themselves, right? So these 2 will be shared together, and likewise these 2 will actually be shared together, right? So what this tells you is that when we start drawing the covalent bonding, whereby they must overlap, this will be the electrons that's involved in the overlapped area. So let me go through with you how to use these 4 steps over here. In terms of drawing the actual dot and cross diagram, we are going to start off first following the step here, which is to draw the individual atoms that are going to overlap. And then what we did was we actually tried to match the unpaired electrons. So what I did was I draw out each of them, then I tried to match those that are lonely by themselves and not being paired. But these electrons must be on the outermost shell. Okay, don't choose those that's inside because they are very stable already. So that's step 2. Step 3, I'm going to start overlapping them, and then I'll put in the electrons. Okay, so now what I'm going to do is I'm going to overlap the 2 diagram. What I can do is I will draw out 1 oxygen first. Be neater so that you don't confuse yourself because of the overlapping of the shell. And this is the other overlapping oxygen. Right? So what is going to happen is that we know that inside this area whereby they are overlapping, these electrons must be inside, this electron must be inside, this electron must be inside, this electron must be inside. Because all of them are being used for sharing. So I can find all of them here in this region. So inside this region over here, which I'm going to shade in yellow, I will be able to find a cross, followed by a dot, followed by a cross, followed by a dot. Now why am I drawing in this manner? I'm drawing in this manner to show that the electrons actually come from both of them, right? So this cross and this dot, this cross and this dot. Right, and they are drawn in an alternating arrangement. That means cross dot because it's called dot and cross diagram, right? So you don't draw all the cross together. And later I'll show you some examples. Okay. Now we're gonna put in the remaining electrons. So oxygen, there's still 2 inside. There's also the 2 that's outside and the 2 that's here. So I'm gonna draw it out here. And for the other oxygen, same thing. There's the electrons that's here. There's also electrons that's inside the 2. And now I'm going to check. So what do I mean by checking? Checking means that look at one of the atom first. Let's say we look at this left side one. And count how many outermost electrons do they have. There's 1, 2, 3, 4, 5, 6 because of the sharing. 7, 8. So now this oxygen has 8 valence electrons, which makes it stable. So this is good. This is correct. Now we check the right side. Over here, I also have oxygen. I'm going to check the electrons again. 1, 2, 3, 4, 5, 6, 7, and 8. Similarly, there's 8 valence electrons, which is what is needed, and therefore it is actually stable. Now, By doing this, you'll get the hang of how you can draw out the structure. So what I need to emphasize is that the final answer that we want is actually not this part of the working, is this structure here. That's called a dot and cross diagram. Okay? In terms of the last column here, please leave it blank first. We'll go through this when we come back to school, right? So what I need to do now is really try to practice it by drawing out for me hydrogen. The formula for hydrogen is H2, so you can start practicing how to draw. And also the next one, which is nitrogen, which has a formula of N2, and water, which has a formula of H2O, and last but not least, methane, which has a formula of CHN4, right? So I want you to practice drawing out the diagram, dot and cross diagram, over these few blanks, right? And once you are done, please use the Adobe Scan app to take a photo and then upload it back into the Google Classroom assignment. If you have any questions, feel free to check in with me, right? This is not an easy concept, right? So if you are lost, please approach me and clarify if needed. If not, that's all. Thank you, and all the best for your learning.